Good day, Bayaws. Welcome again in this channel. So for today's video, we will solve again a problem in thermodynamics, which is specifically in chapter 11, which is all about the combined heat transfer. So to begin, this is our problem. Consider a person standing in a breezy room at 20 degrees Celsius. Determine the total rate of the heat transfer from this person if the exposed surface area and the average outer surface temperature of a person are 1.6 meters squared and 29 degrees Celsius, respectively. And the convection heat transfer coefficient is 6 watts per meter squared degree Celsius. So these are the given values in this problem. First, we have the temperature of the surroundings, 20 degrees Celsius. We have also the surface temperature, 29 degrees Celsius. And then we have the surface area, 1.6 meters squared. And then lastly, we have the convection heat transfer coefficient, which is 6 watts per meter squared degree Celsius. The rate of convection heat transfer from the person to the air is equals to the convection heat transfer coefficient times the surface area times the quantity of the surface temperature minus surrounding the temperature of the surrounding. We will substitute the values. So first, the value of our H is 6 watts per meter squared degrees Celsius, and then the value of our surface area is 1.6 meters squared, and then our temperature 29 minus 20 degrees Celsius. In calculating this, we can get the answer 86.4 watts. So considering that the air does not intervene with radiation and the person is completely enclosed by the surrounding surfaces, the net rate of radiation heat transfer from the person to the surrounding walls, ceiling, and floor is the heat of radiation is equals to the emissivity, then we have the sigma, and then the surface area times the quantity of the surface temperature and the minus the temperature of the surroundings. So again, we will plug in the values because it is already given in our problem. 0.95 times 5.67. So by the way, the value of our emissivity is 0.95 times 1.6 meters squared. And then the value of our temperature. So we will add 273. So the heat of radiation is equals to 81.7 watts. So this is our answer. The rate of total heat transfer from the body is determined by adding these two quantities. So we have the convection heat transfer plus the radiation heat transfer is equals to 86.4 plus 81.7 watts. Calculating this, so our final answer in this problem, we have 168.1 watts.